Hello, 8th grade. Today we are going to work on using powers of 10 to rewrite numbers and then to ultimately add and subtract them. So first of all, we're going to think about a quantity and we want to write it as a product, meaning there's multiplication involved, where one of the factors is always a power of 10. And we want to write assorted different ones, different equations that all give you the same product. So let's start with a product of 50. All right, and we're going to write it, let's say, 4 different ways, where one of the factors is a power of 10. So 50, if you think about 50, you know that 5 times 10 is 50, right? And that would be 10 to the first power. But now I want to write it with a different power of 10. So what if we change this to 50 times 10 to the 0 power? Because 10 to the 0 power is equal to 1, so 50 times 1 is 50. Now we're looking for a pattern. And what happens? So on this factor on your power of 10 factor, we went from 10 to the first power to 10 to the 0 power, which means we reduce the exponent by 1. Now what happens mathematically, in order to reduce the exponent by 1, you divide by that base, right? Remember that pattern of decreasing exponents means you're dividing by that base. So if we divide this factor by 10, 10 to the first divided by 10 does give you 10 to the 0. Now what happened to the other factor though? How do we go from 5 to 50? Well, we multiplied that by 10 to the first power. So what we did is we multiplied one factor by 10, we divided the other factor by 10, and we ended up with an equivalent equation that's still going to give us the same product of 50. All right, so that is the pattern. Multiply one factor by a product of 10 and the other one by divided by a power of 10, the same power of 10. Okay, so let's do the same thing now. What if we started with 10 to the 0 and we divided that by 10? Again, following that pattern of reducing the exponent, that would tell us it would be 10 to the negative first power. And then if we're going to divide that factor by 10, then we need to multiply the other factor by 10. And 50 times 10 is 500. So 500 times 10 to the negative first power still gives us a product of 50. Let's do it again. Divide by 10, multiplied by 10. 10 to the first divided by 10, we're going to take another exponent away, so that would be negative 10 to the negative 2 power, and then 500 times 10 is 5,000. So now we have 4 products, or 4 different products to get the same product of 50. 4 different multiplication problems that give us the same product. So now let's do it again. Let's do it with a different kind of product though. So our product that we're trying to get to is 67 10,000ths. Okay, so you can always start with it as is times 10 to the 0 power, right? Because anything times 1 gives you that same value. So now let's follow the pattern. What if we divide this by 10? That means we need to multiply the other factor by 10. So when we multiply a factor by 10, we shift over one place. So the 6 and 7 would both shift over a place to give you 67 thousandths. And then when we divide 10 to the 0 by 10 to the first, that should be that's a 10 there. That would give you 10 to the negative first power. Okay. And we can keep doing this. We can divide one factor by 10, multiply the other factor by 10, and now we keep shifting. So that would become 67 hundredths times 10 to the negative second. Again, has the same value. Let's do it one more time. And that would give us 6 7/10 times 10 to the negative third power. Now you might notice this last one that we just did is actually scientific notation now, because that coefficient is greater than or equal to 1 and less than 10. Okay, so now we're going to work with some subtraction problems where we have products of powers of 10 in the subtraction problem. Now, in previous years, when you saw a problem like this, you would follow the order of operations, which would tell you to take care of the groups first, that would be what's in parentheses, and then do the subtraction last. And if you did that, 5 times 10 to the first power is 50, minus 5 times 10 to the 0 power would be 5, and that would give you a value of 45. But we're going to try it a little differently. We are going to rewrite one of these groups, one of these products, so that they have the same power of 10. So let's think about how we might do that. If this is 10 to the 0 power in the second expression, and this is 10 to the first, I could make this 10 to the 0 power by dividing 10 to the first by 10 to the first, and that would give us 10 to the 0. And what we've just learned that if we're going to do that and keep the product the same, that means we would have to multiply the other factor by the same power of 10. So now we have 50 times 10 to the 0, which is still equal to 50, which is the same as 5 times 10 to the first. And now what you can see is we have two groups that have the same power of 10, 10 to the 0 power. So now what we can do is we can subtract the coefficients, the 10 and the 5, or the 50 and the 5. So 50 minus 5 times that same common power of 10. So 50 minus 5 is 45, times 10 to the 0 power is equal to 45, which is what we said this needed to be. Now, the only other step we still need to take is that we need to rewrite this answer so that it is in scientific notation. So we're going to do the same thinking. We need 45 to be expressed as 4 5/10, right? Because the coefficient has to be greater than or equal to 1 and less than 10. So in order to do that, we would have to divide that quantity by 10. And if we're going to divide that quantity by 10, we're going to multiply the other quantity by 10, the other factor. So 10 to the 0 times 10 would be 10 to the first power because we add the exponents. So 4 5/10 times 10 to the first power is equal to 45, which is the subtraction answer we got originally. So let's apply that same thinking to this problem. So go ahead and write that down, pause if you need to, and then let's get started. Okay, so we have two different powers of 10, and we need them to be the same power of 10. So because this is a subtraction problem, I'm going to probably deal with the first product, and I want it to be the same power of 10 as the second product. So I need this to be 10 to the negative third. And the way that I could do that is by dividing by 10 to the first power. Because if you subtract those exponents, negative 2 minus 1 gives you negative 3. So if we divided this factor by 10, we're going to multiply the other factor by 10. So 4 1/10 times 10, all the digits shift over, is 41. So all we did was rewrite that product differently, but it still has the same value. Now we can subtract from that 2 6/10 times 10 to the negative third power. Now we have the same power of 10. So we're just going to go ahead and apply the subtraction to the coefficients. And we're still going to be multiplying it times that same common power of 10. So now I'm going to go over here and do the subtraction, knowing I got to keep everything lined up nicely by place, 38 4/10. So 38 4/10 times 10 to the negative third power. And that's great, we've subtracted, but we need to adjust our difference, our subtraction answer, to be in scientific notation. So I need this to be 3.84, right? Because I'm using the same digits, but making it greater than 1 and less than 10. So 3.84, what did we have to do to this, to 38 4/10 to get there? We had to divide it by 10 because we're shifting the digits to a lesser place, which means we have to multiply the other side, the other factor by 10 to the first power. So now when you have your multiplying powers that have the same base, you add the exponents, that would be 10 to the negative second power. Now we have a subtraction answer that is written in scientific notation. So we can apply this same thinking to addition problems, same exact idea. So now this problem has 10 to the fourth power and 10 to the seventh power. So we need to make an adjustment to one of those products so that it matches the other power of 10. So I'm going to make 10 to the fourth power 10 to the seventh power. Now, what do you have to do? You have to add 4 plus 3, right? And when you add powers, it's because you're multiplying by 10 to the third power. So if I'm multiplying 10 to the third power, then I'm dividing by 10 to the third power with the other factor. Now that might not have been the easiest way to do this. We might have been better off on the other side, but that's okay. So now 2 3/10 divided by 10 to the third power means we're shifting all those digits 3 places, right? So the 2, I'm going to write it out on a place value chart here. 2 3/10, and we need to shift 3 places. So the 2 is going to go 1, 2, 3. The 2 is going to go here, and the 3 is going to be behind it, and then I'm going to turn everything else into zeros. So this is 0.0023 times 10 to the 7th. And we're going to add to that 4.16 times 10 to the 7th power. So now I'm going to do some addition, and I'm going to set this up so that I make sure I keep everything lined up. So 3, 2, 6, 1. So 4.1623 is what you get when you add the coefficients. So I should have written this out like this. What we're doing now is adding the coefficients, and we're going to multiply that times 10 to the 7th power, and we just said that is 4.1623 times 10 to the 7th power. Now, what you may already notice is that this is in scientific notation already, which is fantastic. Okay, that is one way to do that problem. I'm going to do that problem again, though, adjusting the other product. Okay, so this time we're going to turn 10 to the 7th into 10 to the 4th. And what do we have to do to get that? Well, we're subtracting the exponent. We're subtracting 3 from the exponent, which means we're dividing by 10 to the third power, which means we have to multiply the other factor by 10 to the third power. So 10 to the third power is 1,000. So if you multiply 4 times 1,000, you get 4,000. So the other digits would just follow. And now we have 10 to the fourth power as the other factor. And now we can add 2 3/10 times 10 to the fourth power. We have the same power of 10. So we can just add the coefficients. So 2 3/10 plus 4,160 times that common 10 to the fourth power, which would be 4,162 3/10 times 10 to the fourth power. Now, in this case, we are not in scientific notation yet. So we got to scientific notation quicker doing it the first way, but now I want to show you how to do it this way. So if you can see that we're still going to keep the same digits, but we're going to have the decimal position this way so that we're greater than 1 and less than 10. And how did we get there? Well, we had to divide this by 10 to the third power because we're shifting 3 places. And if we divide that factor by 10 to the third, we're going to multiply this one by 10 to the third, which would give us 10 to the 7th power. Same result as we got the first go round, but just got there in a different way. So you have a couple of practice problems to work on. You'll find them on Khan Academy. Make sure you use pencil and paper and work them through just like we just did. All right, good luck.